Okay, last time we looked at the addition properties of equality, so today we're actually going to look at the multiplication properties of equality. So hopefully if you remember, the properties of equality pretty much say is that if you have a scale of an equation with an expression on one side, an expression on the other, you have to do the same things to both sides of the equation. That's the property, the properties that we're dealing with here. So you can add the same thing so long as you add it to both sides. You can subtract something so long as you subtract it from both sides. What we're going to be looking at today is you can multiply something if you multiply it to both sides, or the inverse of that, you can divide something if you divide by both sides. All right, so you have to keep this equation, this scale, you have to keep it balanced. Otherwise, it doesn't work. All right, so we just jump right into examples, mainly because most of the core of the information we pretty much got yesterday in yesterday's lesson with the addition properties of equality. So when you're dealing with multiplication, or fractions or whatever, if you have to simplify the expression or solve the expression, you need to get x by itself. Okay, anytime you see that, you want to get x by itself. So when you have 3/5 x equals 12, you need to get that alone. And the best way to do that is to multiply both sides of the equation by the same thing. And when you're dealing with a fraction, remember the identity properties of addition and subtraction and of multiplication. All right, we're using the identity properties when we're doing this. All right, so with the identity properties of multiplication, you're looking for a value that equals 1. All right, so this is what you're dealing with right here. So in addition, you were looking for the opposite. With multiplication, you're looking for its reciprocal. So what you're going to multiply this by is you have the 3/5 x, so you need to multiply this by 5/3, but you need to also multiply this side by 5/3 as well. All right, and that's going to cancel out. Okay, these cancel out, and this just becomes 1x equals 12 times 5/3. You simplify that, you solve that out, and you are going to end up with x equals 20. Okay, so you can do this a couple ways. You can actually do 12 times 5, or the example that they give you is they say, hey, look, 3 goes into 12 4 times, so then you would just have 4 times 5, 4 times 5 is that 20. Okay, so multiplication property of identity and the addition property of identity are what's going to allow you to do the same thing to both sides without changing the equation. All right, so you have same idea, different example, a little less complicated, right? So if we have a negative 4x equals 16, all right, you're going to be multiplying this by its reciprocal, or in this situation, it depends on how you want to write it. So if your brain thinks better doing this, you can do this. Okay, same thing. My brain does better if I do this and just get rid of that. All right, that works better for my brain. It's completely up to you. The reason why this works better for my brain is if you look at that, just very simple to see that it crosses out. 4 goes into 16 4 times. You have a negative that you have to keep in there. So your solution to this is going to be a negative 4 equals x. Okay, so negative 4x equals 16. Divide both sides by the negative 4, and you'll get x equals a negative 4. Okay. And everybody's favorite, decimals. All right, so you have a negative 1.2x equals a negative 36. Okay, you need to get x by itself, divide both sides by 1.2, by 1.2, okay. All right, remember what I told you, the reason why I write it this way is it's really easy just to get rid of those. All right, you have a negative and a negative. These are going to become a positive. All right, so your solution is going to be positive x is going to equal positive 30. Okay, positive 30. 36 divided by 1.2 is going to be a positive 30. Okay, this one's a little bit different. When you're dealing with this one, you have 1/7 x equals 5/9. Okay, so what you're going to want to do is you can't really write this out the easy way that I've been using, because you have to take the reciprocal, right? Because you have a times 1/a equals 1. So what we have in this equation, is this. All right, so we're going to have to multiply by its reciprocal. So the reciprocal of 1/7 is going to be 7. Okay, multiply both sides by 7. All right, your 7s can cancel out, and you're left with just the x over here. And what you get on the other side is 5 times 7 over 9. Okay, so that's going to be 35 over 9, which cannot be reduced. So that is going to be your solution right there. Okay. Now, so far the examples with this have been only dealing with multiplication, all right? But what you guys are going to be running into for the rest of the time is really going to be dealing with combination of the two. So it's important that you guys know how to see and look and pair up the sets, working with the addition property and the multiplication property. All right, so you have, in this example, 4x minus 8x equals 16. All right, now to solve this, you need to look for any like terms. Okay, like terms right here. All right, and you combine those like terms, and you have 4 minus 8 is going to be negative 4x equals 16. You divide both sides by negative 4. This question should be starting to look familiar right about now. When you divide both sides by the 4, the x's can go away. The negative 4's go away, and you're left with just the x over here. So x equals negative 4. You guys have seen this one already. It's just kind of the longer version of question you already saw. All right. So you're going to combine the addition and multiplication properties. Okay, so you have 3z minus 1 equals 26. Okay, so you need to get z by itself. So getting z by itself in this situation means the first thing you're going to want to do is you're going to want to add the 1 to both sides, all right, which would leave you with 3z equals 27. Then you go over here and you divide both sides. Divide both sides by 3. Okay, your 3's cancel out over here, and you're left with z equals 27 over 3. Can this be reduced? Well, how many times does 3 go into 27? Goes into it 3 times. Not 3 times, 9 times. 9 times 3 is 27, so your solution is going to be 9. Okay? And if you're ever unsure, all right, make sure you plug it back into the original equation, and that will probably help you. All right? It's the best way to make sure you don't get a problem wrong. All right? Your next one. This one's going to look a little bit more complicated, but that's okay. What this one really has is it has multiple steps, but a lot of those multiple steps are really just combining like terms more than anything else. So you have 12x plus 30 plus an 8x minus 6 equals 10. Okay, there's nothing you can do on the right side of the equation. That's about as simplified as that's going to get. So you're going to look over here for your like terms. You have some like terms here. And you have some like terms here. All right. So your like terms with the variables, you have 12x plus 8. You're going to add those together. It's going to be a 20x. And you have 30 minus 6. Okay, 30 minus 6 is going to be plus 24 equals 10. Subtract 24 from both sides. And you're left with 20x equals negative 14. Then you're going to want to divide both sides by 20 to get x by itself. 20's cancel. X equals negative 14 over 20. Now the solution is not completely correct right now because you can actually simplify this. 2 goes into both of these. So you would get a negative 7 over 10, and that will be your simplified and your most reduced solution. Okay. And with this one, you're going to want to start off by distributing. So you have 5 times 2x plus 3 equals negative 1 plus 7. All right. So you're going to want to distribute on the left side of the equation, and you're going to want to combine terms over here. So negative 1 plus 7 is the same thing as saying 7 minus 1, which is 6. Combine your like terms, and then you distribute on the left, which would give you 10x plus 15. Subtract 15 from both sides. That'll give you 10x equals negative 9. Divide 10. Divide 10. Can 10 over 9 be reduced? No, it cannot. So your solution is going to be a negative 9 over 10. Okay. All right, this next section looks at writing expressions for consecutive integers. Right, this seems really random. kind of introducing you to a little bit more word problems. You saw that at the end of section 2.1. Same idea for the end of section 2.2. All right, so it's this publisher's way of slowly introducing you to word problems and various types of word problems rather than introducing you to them all at once. They're trying to do you a favor by progressively filtering them in. So if x is the first two consecutive integers, express the sum of two integers in terms of x, and then simplify if possible. So if you have two consecutive integers, the second one is always going to be one more than the one before it. So two consecutive integers, 11 and 12, those are two consecutive integers, all right? This one is the same as that, right? Okay, so two consecutive integers can be labeled as simply being x and x plus 1. All right, this would kind of be the formula, so to speak, that you would use for any consecutive integers. The reason why that's important is you're going to be seeing this again in future word problems. And typically you'll see it in future word problems where you have something like page numbers. If a person's reading on in a book and the sum of the pages of two consecutive pages is like 930, what page did they start on? So it's going to be important for you to remember that the sum, so this would be a good formula to write down, of consecutive integers is going to be x plus x plus 1, or you combine your like terms and simplify 2x plus 1. Okay, you're going to want to write this down. Sum of consecutive integers is 2x plus 1. And that's important because you're going to see that again in word problems. All right, so if x is the first two consecutive odd integers, express the sum in terms of integers. So two odd integers, so let's use the same number we used before, of 11, two odd ones, and 13. Okay, 13 and 11, 11 plus 2 is going to give you that 13. Okay, so that's the same thing as saying x and x plus 2. All right, so when you have to add that and write it as a sum, sum of two consecutive odd integers or two consecutive even integers. Odd or even, you'll see both, is going to be, you combine like terms of x plus 2, you get 2x plus 2. You're going to want to write these down because, like I told you, this is going to show up again, so you're going to wish you had these in the back of your notes somewhere. All right. So you'll see this again, usually in the context I've seen it the most has been in the context of word problems where Joe is reading a book, and like I said, the sum of the two pages that he read is 432. What page number is he on? So it's just stuff like that that you're going to see it in. Instead of, like I said, introducing you to all kinds of word problems at once, they're trying to help you out by trickling them in a little bit. And this is their approach at trickling them in. So what you guys can do is you can get going on the examples for this lesson, and then you should be all set with tonight's homework. So make sure you took decent notes, do the example problems that are posted, and I will see you in class tomorrow.